Namaste. Welcome to today's virtual class, Grade 10, Science and Technology, Unit 14, Classification of Elements. Dear students, we are discussing on the lessons of classification of elements. Today we are in the fourth part of this unit. What did we discuss in the previous lesson? Yes, we have discussed about the metals, non-metals and metalloid which are placed in the modern periodic table. Yes, modern periodic table has periodic classification of elements according to their properties. So, those elements which are metallic, they are placed in left hand side, and non-metallic elements are placed in right hand side. And what is the position of element between metal and non-metal? Yes, between metals and non-metal there are metalloids. Metalloids elements have properties between metal and non-metal. They are semiconductors. Yes, continuing this lesson, today we are going to discuss about other features of the periodic table. Before that, let's review the previous class formally. Yes, which element is it? Do you know? Yes, H represents hydrogen element, and here are some of the notation in the symbol hydrogen. Yes, this is symbol, this is atomic weight, this is name of the element, and it represents 1, that is atomic number. If you study the periodic table, you have to know these facts, isn't it? What are the different informations of the elements are there? You try to understand by the help of this one example. And for the classification of elements, look at here, these elements are represented by different colors. Let's review once again. What does this color represent? Yes, except hydrogen, group 1 is alkali metal, which we have discussed in the previous class, and group 2 represents alkaline earth metal, and other groups, look at it, this last group represents inert gases, isn't it? Inert element, chemically non-reactive element, which we have discussed. And this, look at here, green color block represents non-metal. Here are the some elements which are metalloids, and there are this bluish color block represents transition metals, and down there is also another separate block which represents lanthanides and actinides, which we will discuss in the coming class. Dear students, yes, position of metals, non-metal and metalloid in the modern periodic table. Let's revise once again, which we have discussed earlier. Yes, these are the metals which are placed in left hand side of the modern periodic table. Yes, and what are there in the right hand side? Yes, there are the non-metals, isn't it? And between metals and non-metal, look at here, these are metalloids. And there is another group also after metalloids. Yes, the different elements, different metals are also named as, look at here, alkali metals are soft metals, and they are the reactive metals also. Group 1 and group 2, or group 1A and 2A are the reactive metals, isn't it? They are also called S block elements, isn't it? How do we find S, P, D, F blocks? That we have already practiced in the previous class. So these are the S block element. Their valence shell contain NS1 or NS2 electronic configuration. Similarly, here are hard and less reactive metal. What are they called? Yes, they are called the transition metals, transition elements. Look at it, they are D block elements. Their valence shell electronic configuration remain up to D subshell. For example, iron. We have already practiced the electronic configuration of iron, copper, isn't it? Yes, and similarly there is metalloid group which lie between the metals and non-metals. And what is the position of non-metal? Yes, non-metal are placed in the P block. of the modern periodic table. Now I am presenting this table for you. Here is one activity. Remember students, in group 1 to group 18, there are the different metals, but I am presenting here only A group, isn't it? Because group 1 to 18 are further divided into A and B subgroup. B group are the transition metals, transition elements, which we have discussed. And remember, non-transition elements are representative elements which belong to group A. Yes, 1A, 2A, 3A up to group 0, they are group A. But one question to you is the valency. Let's find out the valency. What is the valency of group 1A? Think properly. Yes, later on I'll tell you, I'll instruct what is the valency. Then group 2A, what is their valency? Group 3A, what is their valency? 4A, what is their valency? 5A, 6A, 7A and group 0. Dear students, please think carefully. Let's have the brainstorming activity to find the valency of the element. Then what is valency? That also you should think, because about the valency, valence electron, valence cell, we have already studied in grade 9, isn't it? Okay, then yes, what would be the valency of the element in the particular group? Yes, we are go on thinking, and let's see valency. What is the valency? Valency is the characteristics of periodic table, isn't it? Characteristics of group and period in the modern periodic table. Yes, we are discussing the main thing, that is characteristics of group and characteristics of periods in the modern periodic table. That is the main focus of today's lesson. So, first of all, let's discuss about the valency. Dear students, look at here. Yes, I have already given one query to you, and I think you came to the conclusion. What is the valency of group 1? Group 1, valency 1. Group 2, valency 2. Group 3, valency 3. Group 4, valency 4. But group 5, valency 3. Group 6, valency 2. Group 7, valency 1. Group 8 or group 18 or 0 group, valency 0. Yes, that is mentioned in the periodic table here. But how it is possible? Yes, let's see one example. Dear students, let's see one example of magnesium. Magnesium. What is the atomic number of magnesium? Yes, atomic number is 12. Magnesium 12. So its electronic configuration is 2, 8 and 2, isn't it? 2, 8 and 2. That means K cell 2 electron, K cell 2 electron, L cell 8 and M cell 2 electron. You have already practiced this electronic configuration according to 2n square rule. So what is the number of electron in the last cell? Yes, 2. And what is the characteristics of magnesium on the basis of this electronic configuration? Sure, magnesium loses 2 electron. So if magnesium loses 2 electron, then what happens? Magnesium, what? Positive charge, isn't it? Magnesium loses 2 electron. That means electron number are lost. But proton number are still 12. Electron number remain 10. That means which is bigger? Proton is greater number, that is positive charge. Metal are electropositive, we have already discussed. So its valency is 2. Valency is 2 because magnesium loses 2 electron. So valency means either atom element loses electron or gains electron or share electron, which we have already discussed in grade 9. Similarly, I'll give another example of chlorine. Chlorine, Cl. Remember, what is the electronic configuration of chlorine? Chlorine has 17 electron, so it is 2, 8, and 7. Look at it. Its valence shell contains 7 electrons. This is the main factor, main cause that represents valency of the element. So what will be the valency of chlorine then? Yes, according to the nature of chlorine, chlorine gains how many electron? 1 electron. So if chlorine atom gains 1 electron, then chlorine gives, what is gain? Positive charge gain or negative charge gain? Yes, positive charge gain, negative charge gain. So it will be chlorine negative charge. This is which ion? Chloride ion. Yes, chlorine is metal or non-metal? Sure, it is non-metal. Magnesium is metal or non-metal? It is metal. Metallic ion, positive ion. Non-metallic ion, negative ion. So this is the valency of the, so valency of chlorine is 1, isn't it? Because it gains 1 electron. Because of this tendency of gaining, losing or sharing electron, valency of element can be determined. Look at here, valency 1 means all have lithium, sodium, potassium. Look at their electron configuration. They all contain 1 electron in the valence shell, isn't it? So they lose 1 electron. So valency 1. Similarly, group 2, valency 2. Why? We have to go through the electronic configuration. Look at here, last cell contain 2 electron. Beryllium, magnesium, calcium all have 2 electron in the valence shell, isn't it? So its valency is 2 because they lose 2 electron from valence shell to be stable. Similarly, group 3 or 13, look at here, boron, aluminum, gallium, their valence shell contain, look at here, 3 electron, they lose 3 electron. So valency 3. Similarly, carbon, silicon, look at here, valence shell contain 4 electron, they lose, gain or share 4 electron to make 8 in the valence shell. 8 means octet state. So their valency is 4. So valency increases from left to right, 1, 2, 3, 4. Then decreases to 3, 2, 1, 0 because look at your group 5, valency 3. Why? Last cell contain 5 electron. So they have tendency to gain 3 electrons, isn't it? Gain or share 3 electrons. So valency 3. Similarly, group 6 or group 17 have valency 2. That means they gain 2 electron because their valence shell contains 6 electron. Look at here, oxygen, sulfur. Valence shell contains 6 electrons. So to make octet, they gain 2 electron. Similarly, in group 17 or group 7a, valency is 1 because their valence shell contain 7 electron. 7 electron means they gain 1 electron to be octet. But the last group, group 18 or 0, why they are group 18 or 0? It is inert group, isn't it? Inert group, that is helium, neon, argon, krypton. There are other elements also. Dear students, let's see 2, 2, 8, 2, 8, 8, 2, 8, 18, 8. Similarly, 2, 8, 18, again 18, then 8, 2, 8, 18, now 32, again 18 and 8. Look at it. There are how many elements? Dear students, 2 electron in the valence shell means helium. This is helium, this is neon, 2, 8, 10, atomic number 10, neon, isn't it? Argon, this is argon. You add, here is 18, 18 argon, then yes, krypton, xenon, radon. Yes, you will total the electron here and you can find the atomic number. What is the atomic number of the particular element? So these elements are the 0 group. Why they are 0 group? Yes, this is duplet. It is duplet, it neither lose nor gain any electron, and these all are octet. Their valence shell contain octet, so their valency is 0 valency of this element is 0 because they neither lose nor gain electrons. So, these chemically inactive or inert element are placed in which group? Last group 18, group 18 or group 0. So, these are also non-metallic elements. Okay, yes, we have represented here by yellow color group helium, neon, argon, krypton, xenon, radon. So, now what is the trend of the change in valency then? Let's conclude it. Yes, valency of an element is determined by the number of valence electrons which we have just discussed, isn't it? And look at here, element belonging to same group possess same valence electrons. Look at here, in a particular group, how many valence electrons are there in the last cell or valence cell? Yes, same valence electron. Group 1, valence electron 1. Group 2, valence electron 2. Group 7, look at here, valence electron also 7. Group 0, valence electron are 8 except helium, which does not determine the valency. So, and in a period, valency of the element goes on changing in the order, look at it, 1, 2, 3, 4, 3, 2, 1, 0. Remember 1 second. 1, 2, 3, 4, 3, 2, 1, 0. Is it clear? Yes, this is the properties of group and period in the modern periodic table. Isn't it? Valency of element remains same in the particular group, but valency of element goes on changing from left to right in a period. Dear students, let's discuss about the another characteristics of the elements in modern periodic table, that is atomic size. Do you know atomic size? Size of atom, that represents the radius of atom, isn't it? And atom is assumed as the spherical shape, so it has the radius. And dear students, here we have to discuss on the basis of this particular group, that is group 1, 2, 13, 14, 15, 16, 17, 18, that is group A. Group A are normal element, representative element. So, look at it. What is the position of atomic size of the element when we go from top to bottom in a group and move left to right in a period? Look at here. Yes, this is the largest, second largest, then smaller, 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 and the smallest. Look at it. When we go from left to right in a period, what happens to the size of atom? Increases or decreases? What do you see in this chart? Yes, definitely. Atomic radius, atomic size decreases from left to right in a period. This is the main thing. But when you go from top to bottom in a group, then what happens? Atomic size goes on increasing. Look at it. Lithium is smaller than sodium. Sodium is smaller than potassium. Potassium is smaller than rubidium. Yes, like this, isn't it? From top to bottom in a group, atomic size increases. Left to right in a period, atomic size decreases. Do you know the reason of it? Why it happens? Think carefully. Yes, in a group, atomic size or the atomic radius of the element goes on increasing on moving from top to bottom in a group. First of all, we are discussing about group character, isn't it? But why? Yes, give reason. Such type of question can be asked in exam. Do you know? Let's check once. Look at it. Lithium, first cell 2 electrons, second cell of lithium has 1 electron. After lithium, there is sodium. Sodium first cell 2 electron, second cell, how many electron in second cell of sodium? 8 electron. 1, 2, 3, 4, 5, 6, 7, 8. And the outermost cell contain how many electron? 1 electron. Similarly, in potassium, in the case of potassium, look at here, first cell 2 electron, second cell, similarly 8 electron, remember. Third cell also 8 electron, and the final cell contain 1 electron. Then what do you see here? Yes, is size increasing, decreasing, or remaining constant? Sure, it's, look at it, radius is increasing gradually, isn't it? From nucleus to the valence shell is the, yes, its radius, and its radius it is increasing. So its strain is increasing because the number of cells are increasing. Here are only 2 cells, here are 3 cells, 4 cells. As the number of cells increases, its size also increases. Then what happens? The distance, there is nucleus, positive charge nucleus has contain proton, isn't it? Proton attracts the electron, valence electron like this. Remember, it determines the reactivity also. Which is highly reactive then? Do you know? Which can lose 1 electron quickly? Yes, definitely this is reactive because it loses 1 electron quickly than lithium and sodium. So its atomic size increases, its reactivity also increases in metallic element. Dear students, you got the answer of this query. Now it is because as the number of cell or energy level increases, the distance between the nucleus and the valence electron also increases. That leads greater atomic size or greater atomic radius, which I have shown in the board, isn't it? So lithium, sodium, potassium. Potassium has greatest atomic size among 3. Dear students, talking about the atomic size, let's discuss about the period, isn't it? What do you see in the period? Look at it. On moving from left to right in a period, look at here. Atomic size goes on decreasing gradually, isn't it? Decreasing gradually. Yes. Atomic size goes on decreasing on moving from left to right in a period. But what is the reason of that? Do you know its reason? Think carefully. Its main reason is that as the number of electron increases in valence shell, the orbit can be attracted towards the nucleus, because look at here, 11 proton, 12 neutron, first cell 2 electron, second cell 8 electron, and outer cell 1 electron. Another element, atomic number 12, 12 proton and 12 neutron. Which element is it? Try to find, try to identify the element. 2 electron, 1, 2, 3, 4, 5, 6, 7, 8. And the outer orbit contain how many electron? 2 electron. Look at it. Now, here is attraction force between nuclear positive charge in the nucleus. What holds the positive charge? Proton, isn't it? Proton has positive charge. And look at here. Here are the electron number are increasing, isn't it? Electron, here is only 1 electron. It is attracted by the nuclear positive charge. Here are the 2 electron, look at it. And 2 electron are attracted towards the nucleus. Can you guess? Whose atomic size is bigger? It is sodium 11, it is 12 magnesium. Whose size is bigger? I think electron number are more, so its size should be bigger. No? No. Electron number, as the electron number in valence shell increase, it is attracted towards the nucleus. Isn't it? Nuclear positive charge attract the electron. So the cell can be concentrated to the nucleus. So its atomic size is smaller, isn't it? Sodium atomic size is bigger, isn't it? Bigger than magnesium, remember. Sodium atomic size is bigger than magnesium. This is a trend in the modern periodic table. Let's check here from the chart, isn't it? Look at it. So atomic size gradually increases from left to right in a period, isn't it? From top to bottom, it goes on increasing. From left to right, it goes on decreasing. As the atomic number increases, valence shell, valence electron increases, then atom is more concentrated towards the nucleus. But it is quite exceptional case in the zero group element. Look at it, helium, neon, argon, krypton, xenon, radon. Why they are quite bigger? because they are chemically inactive. So yes, except this, other have this general trend. So its answer is like this. It is because as the number of valence electron increases, moving from left to right in a period, the valence shell gets attracted more towards the nucleus or positively charged proton, which I have demonstrated, causing smaller atomic size. That is the main cause to determine small atomic size. Dear student, atomic size is clear, isn't it? In a group, atomic size goes on increasing. In a period, atomic size goes on decreasing. Another characteristic is electronegativity and electropositivity, isn't it? Let's discuss what is electronegativity, what is electropositivity, isn't it? Electropositivity, electronegativity we can observe from this table. Look at here, lithium and beryllium. We compare two elements, lithium and beryllium. Which is more positive, lithium or beryllium? Which is more positive, sodium or magnesium? Check the valence shell. Valence shell contain 1 electron in sodium, valence shell contain 2 electron in the magnesium. Which loses electron quickly, sodium or magnesium? Definitely, yes, sodium loses 1 electron quickly. So sodium is more positive than magnesium, isn't it? Sodium is more positive than magnesium. And it is about the period, isn't it? That means metallic character. This is metallic character or electropositive character, isn't it? As the metallic character increases, that means electron losing capacity increases, electropositive character also increases. Element that loses electron is electropositive, isn't it? Element that gains electron is electronegative. So electropositivity means capacity of losing electron to become positive charge, that is positivity, isn't it? So what happens to the positivity from top to bottom? Look at it. Let's check in the metallic group 2. Let's check group 2. Beryllium, magnesium, calcium. Which is more positive? Beryllium, magnesium or calcium? These three elements, three atoms have the 2 valence electron, isn't it? Beryllium also loses 2 electron, magnesium also loses 2 electron, calcium also loses 2 electron. But which loses quickly? Sure, yes, calcium loses quickly because its atomic size is bigger, atomic radius is bigger. So which is reactive, that is more metallic, that is more positive, isn't it? So this trend, positivity goes increasing from top to bottom in a group, but positivity goes on decreasing from left to right in a period, because in the left hand side metallic element lose electron, but right hand side they don't lose electron, isn't it? They gain electron in the right hand side, that means non-metallic. So this is the trend in the electropositivity. But electronegativity, yes, look at here, lithium, sodium, potassium don't give electronegative charge because they don't gain electron, they lose electron. So their electronegativity is weaker, which gradually increases from left to right. Electronegativity goes on increasing. Suppose fluorine, chlorine, bromine, they are highly electronegative because they gain electron, they never lose electron, isn't it? Yes. So this is the characteristic. Let's check it again. Yes, this arrow shows that increase of electronegativity. Look at it, increase of electropositivity. This side electropositivity increases, the arrow head shows this left hand side, but decrease of electronegativity. Left hand side elements are less negative, more positive, isn't it? But what happens to the right hand side? Yes, increase of electronegativity. Electronegative element increase. Suppose carbon is less electronegative than, yes, nitrogen. Nitrogen is less electronegative than oxygen. Oxygen is less electronegative than fluorine, isn't it? Similarly, what happens in the top to bottom? Think carefully. I'll show arrow and this increasing and decreasing trend. But decrease of electropositivity, look at it, in right hand side electropositivity character decreases. What happens then in the top to bottom? Top to bottom, look at it, this is increase of electropositive character and decrease of electronegative character, isn't it? So, what is electronegativity and electropositivity then? Let's discuss. This is metallic character, have electropositive character. Non-metallic character has electronegative character. And now, what is the definition of electropositivity? Tendency of element to give electropositive ion by losing electron is called the electropositivity, tendency of losing electron from valence shell, isn't it? We have studied valence shell electron, their tendency of losing electron. So, that is the electropositivity, isn't it? In a group, electropositive character, what happens? Increases from top to bottom. Yes, top to bottom electropositive character increases because atomic size increases. So, atomic size and electropositivity are correlated, they are complementary, isn't it? And yes, so from left to right in a period, what happens from left to right in a period? Left to right, it is metallic to non-metallic, then electropositive to electronegative character increases, that is electropositive character decreases. Similarly, let's discuss what is electronegativity. Yes, tendency of element to give electronegative ion. How electronegative ion is given? By losing or gaining electron? Sure, by gaining electron, isn't it? By gaining electron to the valence shell is known as electronegativity. Suppose look at here, fluorine has 2, 7, that means first cell 2, second cell 7 electron. How many electron it gains? 1 electron. So, it is highly electronegative. 1 electron it gains. Fluorine, chlorine, bromine are electronegative. Similarly, oxygen gain 2 electron. Sulfur gain 2 electron. This is electronegative. In a group, electronegative character decreases from top to bottom, isn't it? Top to bottom, look at here, electronegative character goes on decreasing because its atomic size increasing. So, but left to right in a period, yes, left to right in a period, it goes on increasing, top to bottom, electronegative character decreases. Dear student, another property is chemical reactivity. Yes, I have already explained about chemical reactivity and the size of atom. As the size of atom increases, then it impact on the chemical reactivity also, isn't it? Let's check in the metallic element and non-metallic element, what sorts of chemical reactivity we observe there. Yes, look at here, in metallic, chemical reactivity increases from top to bottom in a group, isn't it? Why? Atomic size increases, isn't it? Radius increases. So, tendency of losing electron increases. Metallic element lose electron, so that tendency increases from top to bottom. But what happens to non-metallic element? Yes, top to bottom, that reactivity decreases. Look at it. Here, if we compare fluorine, chlorine and bromine, which is highly reactive, yes, this arrow represents that fluorine is highly reactive. How it is reactive? Fluorine gains 1 electron quickly than chlorine because atomic size of fluorine is smaller than atomic size of chlorine, which you have seen here by the electronic configuration, isn't it? Fluorine has 2 orbit, chlorine has 3 orbit. Yes, this is the trend of chemical reactivity of the elements. So, in a group, metallic character and the metallic chemical reactivity increases from top to bottom. In the metal, that is left hand side where metals are placed, and decreases in non-metal, non-metal are placed in the right hand side. In a period, chemical reactivity of metal decreases and that of non-metal increases along a period. From left to right, chemical reactivity, look at here, it is highly reactive. Smaller size has highly reactive in non-metal, bigger atomic size has the highly reactive in the metallic character. That means element in extreme right are chemically inert. Means, look at here, extreme right, what are there? Helium, neon, argon, krypton, xenon, radon are the chemically inert elements. Dear students, now we came to the end of the class, so let's perform one project activity. What sort of project activity we have to perform? Yes, please, you do this activity, prepare atomic model of the group 1 element, that is lithium, sodium and potassium, and group 7 element fluorine, chlorine and bromine with clear representation of the increasing atomic size. Which is bigger? Lithium, sodium, potassium. Increasing atomic size you have to mention there, represent there in your project, isn't it? And you have to demonstrate in your class. Dear students, there is another option of give reason question, isn't it? That you have to complete. Suppose some of the questions are here. Sodium is more reactive than lithium. Why? Yes, you have to consider about electropositive character and atomic size. Sodium atomic size is bigger, which lose one electron quickly. Second question is electropositivity increases from left to right in a period. Why? Yes, atomic size gradually decreases from left to right in a period, isn't it? That means elements are metallic to non-metallic. Non-metallic character increases, which are less electropositive and more electronegative. Third question is size of atom goes on increasing from top to bottom in a group. Size of atom goes on increasing from top to bottom in a group, because as the atomic size increases, yes, number of valence shell are increasing from top to bottom, so atomic size increases. That answer you have to write. Similarly, another question is fluorine is more reactive than chlorine. Why? Because atomic size of fluorine is smaller than atomic size of chlorine. So fluorine gains one electron quickly than chlorine, isn't it? It is related to reactivity. Okay, dear students, let's do another activity. Choose the correct alternatives. Here are some of the multiple choice question. The first question is, which of the following represents the correct order of the increasing reactivity? Look at here, options are here. Chlorine is reactive than bromine, bromine is reactive than fluorine, or fluorine is reactive than chlorine, chlorine is reactive than bromine, or chlorine is reactive than fluorine, fluorine is reactive than bromine, bromine is reactive than chlorine, chlorine is reactive than fluorine. Which is the correct reactivity order? Yes, sure. These are the non-metallic element. Did you think? Okay, let's check it. Fluorine is reactive than chlorine, chlorine is reactive than bromine. Yes. Now, let's discuss about question number 2. Question number 2 is like this. Which of the following possess highest reactivity? Beryllium, magnesium, potassium and sodium. Try to find the correct answer. Beryllium, atomic number. Try to find atomic number and valence electron. First of all, we have to check the valence electron. Beryllium has 2 valence electron, only 2 orbit, K and L. Magnesium has 2 valence electron, K, L, M, 3 orbit are there. Potassium has 4 orbit, K, L, M, N. Sodium has also 3 orbits, isn't it? So out of them, which of the following possess highest reactivity? Yes. What is the valency of potassium? 1. Valency of sodium? 1. But beryllium and magnesium, they have valency 2. Elements with 1 valency is more reactive than valency 2. So out of them, potassium and sodium, which is more reactive? Sure, potassium is highly reactive. It should be the correct answer. Yes? Okay. Now let's discuss question number 3. which of the following represent the correct property of period? Let's check the alternatives. Metallic and electropositive character increases gradually from left to right. Is it correct? Second option is metallic and electronegative character decreases gradually from left to right. Is it correct? Third one is metallic character increases but electropositive character decreases gradually from left to right. And the last option is metallic character decreases but electronegative character increases gradually from left to right. Let's think. Yes. Let's check the correct option. Sure. Metallic character decreases from left to right. And electropositive character decreases, electronegative character increases gradually from left to right. Isn't it? This is the correct answer. Dear students, we have discussed about periodic trend, that is the properties of metals, properties of non-metals, and we have discussed about the different metals, non-metals, and periodic trend, that is characteristics like valency, how valency are changing in the period and group, how metallic character are changing and non-metallic character are represented in the period and group, and similarly size of atom, electropositivity and electronegativity are also discussed. I think you enjoyed today's class, so its remaining part we will discuss in the coming class. And this much for today. Thank you. Namaste.